Hi. So far we have seen turning toolpaths. Now we are going to see now C-axis toolpaths. So far what we are seeing is X and Z axis configuration. Then now we are going to see X, Z and C axis. So three axis programming. Okay. So X, Z is the linear axis and C is the rotary axis. It comes under the three axis machining. Here if you see there are six tool paths: face contour, face drilling. This is one set. C axis contour and C axis drill, the second set. And third one is cross contour and cross drill. So like this there are six tool paths are available. Now I have made one small example for you to explain. So there are drills are there, and at the front there is a hexagon. We are going to make the tool path for this. Initially we will make the stock setup now. So I'll select from the origin to the top of the stock. Okay, preview. So now stock is ready. Now we are going to clamp. Okay, I'll accept this. I'll go for holding. I'll select the same job, whatever it is there, and my holding position is from center of that line. Okay, so you can see that it's look like this, and if you switch on the visibility, it will look like this. Now job setup is ready. But the wireframe I have not done it. I'll do one thing. Okay. Now I'll make a profile which is already there. I'll just check it. Okay. I already made the turn profile. I just brought outside. So if you see from the top view, the turn profile is look like this. Now I'll go for turning, roughing toolbar. I'll select the chain. Okay, so this is the endpoint. I'll select the tool and other parameters which is needed. I just direction of the tool I am just looking here. Left hand spindle, top turret, and the, so now the tool is ready. The parameter whatever needed I am here, and use stock for outer boundary. I already selected, and this is the roughing. Okay, you can add one more finishing tool for use the last option. Select, then you take a finishing tool. Again you just check the setup, top turret, and the turn spindle clockwise. Okay. Okay, parameter I just accept as such. I just made the roughing and the finishing now. What is left out is the C-axis machining, that is C-axis face contour and the face drilling. So now we'll check the turning by backward, how it is look like. Now this is simulating both roughing and finishing together, and this is a finishing operation. Okay, I'll accept. Just this is what we have already done. That same thing I repeated. Now we'll see the C-axis face contour. If you want to do the C-axis face contour, you need to do important thing is your construction plane should be at the right side. Just click on C plane. It should be a right, because the tool is coming exactly 90 degree to the uh, uh, exactly 90 degree to the chuck. So your C-axis while doing C-axis cutting work, the construction plane should be right. Then only it will work. This is very important. So it should be in the right C-axis. Then only you can able to do C-axis roughing and drilling. Okay. I already selected C-axis. C plane right side I have taken now. Always the T plane is equal, C plane is equal to T plane. Okay. Now we'll go for C axis face contour. I will select this hexagon chain. Okay. Now you see the direction of arrow is it is showing upward, means a clockwise direction. So now we need to decide whether tool should be in the left hand side or right hand side. But our requirement is outside removal, so it should be in the right hand side. Sorry, left hand side. Okay. This window is look like similar to the milling what we have done it. Now you can see that same as milling uh, window. So you can select the flat and mill. I will select 10 flat and mill. If you want, you change it to 12 flat also. That is based on the tool availability in the workshop. So the tool number should be same number of the tool mounted in the turret. And also you can change your cutting speed and spindle speed according to your material. Whether you are giving CS or RPM is up to you. And feet per tooth or feet rate. Anything you can give. But remember that the plunge rate should be lesser than the feed rate. Okay. Now I have given everything in this page. Now if you want, you can select your holding. So it is similar to your milling. So compensation I changed to left hand. Depth of cut I just modify to 1 mm. Okay. Then lead in lead out I just if you want you can make it. It's better if you switch on this lead in lead out. Mm, it is based on the percentage of tool diameter. I am changing this both, and I'll give 75% of tool length, and this is the 50% I am given. The same thing I need in the exit also. So I just click there, then it will happen in both. Now multipass breakthrough is not required now. Now we are going to depth. You can select directly by clicking there depth, or otherwise you can enter also. Keep absolute in this thing. You can keep absolute. You can go and select that edge point. Okay. Now you see that it has already taken. I just switch on the coolant now. Okay. Now you can see that toolpath is generated. The red color and green color is lead in, lead out. And if you want to change the entry position, you can change. Select chain and right click, change the start point. Okay. So you can make it select the dynamic and keep wherever you want to start. Okay. Accept it and regenerate it. Now we have changed the start point also. Okay. First we will check it how it is look like by doing the simulation, solid simulation. Uh, okay, I have to select all. Not done it. Okay, now I'll redo it. Now roughing is over. Now it's cutting the C-axis. So it is not clearing the outer material. This you can clear by either by increasing the tool diameter, or you can add the multipass. Now I am adding multipasses. Uh, you can give two passes, no problem. Spacing 6. Okay, 50% of tool diameter you can give. If you want to finish pass, one pass you can add it, no problem. We have not kept any stock now. Regenerate. Now you can check. Uh, why we added multipass to? The thing is we need to clear our outer material also. And additionally we have added one finishing pass. Okay. Okay. This is the C-axis face contour toolpath. That's the first example. Okay. Uh, there is one option available. Just I am searching that. Let me see. It's available. I will explain. At present, the work is stationary and the tool is rotating. This can be reversed. You can reverse it. That simulation can be reversed. Means the workpiece will rotate and the tool will be stationary. Okay, I'm searching that option. It's not visible at the moment to me. So we'll do it in the next coming thing. Okay. Now we'll see face drill. No, here that the contour shape, any shape you can make on the outer profile. So if you want to see the how the output is look like, you can generate one NC file and see. So this is the all all the program is in the X and C axis. Okay, this is the C axis contour programming. Next, we need to do the drilling. So we'll go there and select face drill and select the drill points. center point, it should hold the center point. 4, 5, 6. I think I have made wrong here. Oh, sorry, it is not selecting at all. What is wrong? I will do it again. I'll close this. No. Face contour. Okay, I select directly now. See? Now it is selecting. I think I have made something that's the reason it has not taken. Okay. Then by selecting that point, automatically diameter also will come. Now we can go select the. First of all, we need to do the center drilling. So I'll select the center tool number. I will change it because both are showing 1. I will make the tool number 2 here. Cutting speed I keep very less because it's center bit. So I keep 12. Make it a spindle speed 1000 and feed rate is um, I just given the feed rate. Why it is less should be less. Okay. Mm, so depth you can here clearance you can give 5 mm. Retraction 2 mm. Top of stock 0. Depth -2. Just switch on the coolant now. Okay. Over. The center drill is over. Sorry, I have not selected the whole size. Just let me check it. Dynamic. So 10 drill is 10 dia drill is needed. Okay. So now I will copy this the same tool path and paste it. I will change the drill diameter and drill depth. I will change the drill diameter to dia 10. Use the feed rate and spindle speed. Then change the cutting method to factor line. First pick 5 mm, consequent pick 4 mm. So that final depth will give minus 12 mm. If you want a tip compensation, you can switch on. So additionally 0.2 I am giving, and the remaining thing whatever the 118 degree whatever the conical is there, that is added. Now I will regenerate it. Okay. Now all the things are over. Now so with this we have finished the face contour and the face drill. Both the cases you need to remember that uh, it should be in the right side. Means your C plane should be right side. The next question is a solid model is necessary? No, not necessary. You can do by wireframe itself, but here I have made the solid model in order to make you to understand. That's the reason. It's not necessary that it need a solid model. Okay. So for you, for understanding only, I have made the solid model. Here there is no need for solid model. Everything you can do it by the wireframe model. Okay, let us see the simulation here. So this is the now we'll see the drilling output. So now you can see that oh G83 है. Oh, it is comes in the y-axis, not the c-axis. Okay. So programming in c-axis and y-axis is not a big difference here in Mastercam. Just you can change your axis configuration from c-axis to, if you give y-axis means y-axis output will come. If you give c-axis means c-axis output will come. Now I change it to c-axis. Let us generate and see. I just regenerate. Axis control I selected. I changed to rotary control to C axis. Now I am taking output NC file output. So now you can see that C axis output. C axis clamping M23 means C axis is switching on. C90. After G83 you can see that just tool is that C axis indexing, and finally G88 is. So the same thing I am just modifying to Y axis. So this y-axis is possible if the machine should have the y-axis configuration, otherwise it is not possible. If the machine is having y-axis, you can switch over the output either c-axis or y-axis. Okay, so I just changed and showing you the c-axis output how it does look like. So it's not the big thing whether c-axis you are doing or y-axis doing. Programming, it is based on your machine capability. If the machine has capability, you can in Mastercam you just switching over the c-axis to and the c-axis and the y-axis. Okay. Now we'll see the contour machining whether it is c-axis. So it is c-axis. Okay. If you see the output of c-axis, it's look a very lengthy program. But the same thing if you do it in the y-axis, it is very short program. The reason behind is, the reason behind is in c-axis that y-axis is converted into into c-axis. This y-axis machining possible only your machine should have the y-axis capability. If the machine is having both C and y-axis, you can take the output c-axis output or y-axis output. If the machine doesn't have the y-axis means you should use only c-axis. You should take only output in c-axis only. If the machine is having x, y, z and c means it is a fourth axis naturally, no? Okay. So So in case your machine is having all four axes X, Z, C and Y, then you can take the output in the combination of means X, Z, C and Y also. So suppose your machine doesn't have the y-axis configuration, so you have to do your program machining by using c-axis itself. So why we need to do the this c-axis programming means if the machine doesn't have the milling option means after turning you need to remove the job and keep it in the milling machine and reset the zero. So there may be chances our positional accuracy may be changed. So if you do turning separate, milling separate, then you will not get the positional accuracy. But in this case, you are holding the job, you are doing turning the same setting, and the same setting you are doing the milling also. So you will get the very good positional accuracy in the in this type of machine. This is the major advantage of the this C-axis machining center. Okay, we have seen C-axis face contour and face drill. Okay, so this so okay next we other set of toolpath we'll see. Okay, thank you.